welcome to ToKCast for a special episode, an omnibus type episode, so to speak. 99 minutes for my 99th episode devoted to The Beginning of Infinity, the book that started my podcast. This is going to be not a typical episode in the sense that often what I do is read part of the book and then reflect upon that book. Instead, what I'll be doing is simply giving nothing but my reflections without ever referring directly to the book. There'll be very few quotes, there might be one or two here, but I'm not going to have the book in front of me and reading passages out of it. For that, of course, you can go to the rest of my podcast series on The Beginning of Infinity, where I do extensive readings and longer reflections. This is going to be very much a personal set of reflections on what I got from each and every chapter from The Beginning of Infinity. So it'll be very much in my words and shouldn't be taken as representative of what really is in the chapter. David provides summaries at the end of every single chapter, and I guess they would be his main points, but this will be my main takeaways from the book. And at the end of each chapter that I discuss, I'm going to give the 2 or 3 sentence summary of what I think that chapter was about. And again, nothing official in this. This is just my takeaway. So many people out there might quite disagree with what I'm taking away as the central message of that chapter. The Beginning of Infinity is special in many ways. Firstly, as Naval Ravikant has said, there seems to be many people who purchase the work, somewhat fewer readers of the work, and fewer still people who actually have a good understanding of what's being said there. This is somewhat perplexing to me in a sense because I don't know why people wouldn't persevere with the book. I get why you wouldn't start the book to begin with. It's a fairly large tome and maybe you just want it to look good on your shelf there. But if you begin reading it, surely you find it captivating. It's amazing. I mean, it's providing you with a different worldview, a different way of seeing not only science and progress, but just about every area of human interest is in some way or other captured there within The Beginning of Infinity. And it provides an optimistic alternative to all of those other misconceptions and worldviews that are out there at the moment. I'm somewhat reminded of what Popper said when it came to problems in one's life. He said that, essentially the purpose of life to some extent is to meet a problem, to see its beauty and to fall in love with it, to get married to it and to live with it happily till death do ye part, unless you should meet another and even more fascinating problem. End quote from Popper. Well, much the same could be said of a good book or even a sublime book like this one. To meet it, to see its beauty and to fall in love with it and basically to spend days and weeks poring over it. I'm sure some books are possibly pumped out rather quickly, like so many blog posts are. I know the feeling of having a particular thought, tossing it over in my mind for a while, and then feeling the urgent need to commit it to the page in the form of a longer or shorter blog post. I tend to think it over sometimes for only a matter of hours before committing it to the page. But I also know the feeling of having an idea, committing it to the page in draft form, and then tossing it over for days and weeks until it's refined to the point where I think, yeah, that's worth publishing. And so I think that many other books, like popular science books and things, they tend to read a little bit like blog posts of the first kind. There's something the authors have just had to say and had to publish very quickly, or perhaps they've tossed it over in their minds for weeks and months, perhaps a year or two in some special cases. But I know The Beginning of Infinity took something like a decade to write, and it really does show. The Beginning of Infinity stands apart because each page really does have a new insight. It's often something that counters prevailing misconceptions, and it's clear, exceedingly clear, and not merely clear, but eloquent. And this sets it apart. But the fact that it is so insightful, I think, is one reason that people might not at times persevere or even see the subtle importance of what's being said. If you're being hit rapid fire on every page with new ways of thinking about things, one might dare say everything's, it can be disorienting. And of course, this is the reason for my channel here and the podcast that I produce and the blog posts and so on, because as so many others have said, some sentences in The Beginning of Infinity could be entire paragraphs. Some paragraphs could be entire chapters, and some chapters could be entire books in themselves. So some unpacking and discussion is not necessarily needed, but it is warranted. It's fun to engage with this stuff and see where the new ideas could potentially lead and how they might inform science, philosophy, decision-making, and thinking and progress broadly. So this episode is an unusual one. The plan is this. I'm going to take about 4 to 5 minutes per chapter and just highlight what I think is important, what was key for me out of that chapter. As I say, this time, no quotes, no reading, nothing direct, maybe except some incidental quotes here and there that I might remember off by heart or I feel I need to just pull out of the book. But in the main, it's going to be my interpretation of the chapters. So it's more like a translation of a kind. So it's more like the beginning of Infinity filtered through me in a sense. So expect to lose something. Expect to lose a lot in that process. As I always say, none of this is a substitute for the book itself. At 18 chapters and 4 to 5 minutes per chapter, that gives me a few minutes here at the beginning to do this introduction and maybe some minutes at the end to do a little bit of a conclusion. And what I'll do with these 4 to 5 minute breakdowns of each chapter is probably just publish them separately on Twitter as well as putting them together here and now for you as a complete podcast. And the reason for that is, once again, I hope it really does entice people to pick up the book and delve more deeply into it. I know I've already done the 45 episodes on the beginning of Infinity, and that is, in fact, close to 2 complete days worth of continuous beginning of Infinity content, not counting the questions with David and the other things that I've published as well. But this is an interesting challenge. I think it's important to accept the reality sometimes that some people simply won't ever read the book. But the ideas in this book are just so important, especially right now, and will continue to be, that we need to repackage them over and over again in formats more accessible to some people. The Naval podcast is doing that, I think, very successfully if the feedback is anything to go by. Naval has great reach, of course, and extremely helpfully a deep understanding and appreciation of these ideas, and one hopes that anyone inspired by Naval when it comes to the beginning of Infinity and the fabric of reality will turn to those books. And so that's what I hope to do here as well. Turn to the book for more details, of course. There's so much Popper and Deutsch content out there now. All of David's interviews in various places and the various other podcasts that are out there now as well. The Do Explain podcast, the Fallible Animals podcast, the Theory of Anything podcast, the Lunar Society podcast, to name just a few. David has really inspired an entire ecosystem of online podcasts and YouTube channels and blogs. So it's really getting difficult for someone who's a big fan like me to even keep up with everything that's out there now. And so I guess personally, I'm not really helping things right now by producing yet more beginning of Infinity content. It's an embarrassment of riches to some extent. And I don't just mean the Popper and Deutsch related material. I also mean the broad intellectual science, philosophy, broadcasting space. All that said, I think our corner, the David Deutsch corner of the internet, really is still David against Goliath. David being David Deutsch and the rest of us on his side of the ledger, and Goliath being, well, mainstream misconceptions, mainstream academia and intellectual culture and all those other kinds of so-called rationality that are out there. Some better than others, but none quite getting to the heart of the matter about why it is we need to be optimistic, why it is that we continue to make progress, and what it is about science and philosophy and reason that really sets humanity apart at this particular epoch in time and the people in the Enlightenment tradition as compared to everything that has gone before. As I say, at the end of each chapter that I'm about to go through, I'm going to give you my personal key learning from the chapter, emphasis on my. Others might very well take something else more important away, and maybe David's intention was something completely different to what I say is the central message that I got. Of course, the worst thing about even attempting this, of course, is that I've already said that each chapter could be an entire book in and of itself, so why would I go in the opposite direction and try and reduce the chapter to a few sentences? I just thought it'd be a cool, curious little challenge that I'd set for myself. So without further ado, let's get to my brief reflections upon each chapter in The Beginning of Infinity, the most groundbreaking work so far of the 21st century. Chapter 1. the reach of explanations. In this chapter, David Deutsch makes some genuine progress in epistemology. Prior to Popper, we had this notion of empiricism, that the way in which knowledge was generated was you went out into the world and you observed the world, and from your observations you managed to derive knowledge from those observations in some way, shape or form that was never really specified. Empiricism at least put observation at the centre of knowledge creation. It was a relief to be relieved from superstitious notions of how knowledge might be generated, or the idea that certain authorities possessed the knowledge, the final truth to a certain extent, or the best version of a truth, and everyone else should agree with what the authority said was known or said was true. We know that empiricism can't be true because we know that, well, seeing is not believing. Our go-to example in The Beginning of Infinity and various other places, and the one which I always turn to, is this idea of observing stars at night and seeing small, dim points of light. But is that what a star is? A small, dim point of light? No, and no amount of repeatedly making those same observations over and over again can get you one jot closer to the nature of what a star really is. What we now know is that stars are not cold but hot, not dim but bright. They are extremely distant, hot furnaces fusing hydrogen nuclei, protons, into helium and other more complicated processes as well. And we only get to that notion, not because we can actually observe the core of stars where these reactions are taking place. In fact, it's very rare for us to be able to observe directly a star. Whenever you take even a powerful telescope, the star still appears as simply a point of light. There are a few exceptions. So we're not observing stars directly at all, let alone the reactions that are going on inside them. So how did we get this knowledge? We had to conjecture it. We had to guess it. And then the function of our observations using telescopes and various other things was to criticize those theories. And insofar as those theories were criticized and survived the criticism, then we accepted that we had learned something new via this method of conjecture, as Popper told us, about what the nature of stars are. Eventually, our theory of stars became a good explanation. And what we mean by good explanation is something that is hard to vary. And this is the insight that David Deutsch provides us in Chapter 1. It is a genuine epistemological discovery. Prior to David Deutsch, Popper rightly demarcated science from non-science via this criterion of falsification. However, as David points out, falsifiable theories are a dime a dozen. After all, any crank wearing a sandwich board on the corner of the street saying the world is going to end next Tuesday has a falsifiable theory, and it will be falsified. But simply because it's a falsifiable theory doesn't make it scientific. Just because it's testable doesn't make it scientific. Someone can say, eat a kilogram of grass, it'll cure your common cold. It's a falsifiable theory, but that does not make it scientific. So what is David Deutsch's great insight? What we're after, not only in science, but everywhere, are good explanations. And a good explanation is something that accounts for what is really going on in the world, and which also is hard to vary, which means every single part of the explanation serves a purpose. And in this view, therefore, experiments and observations serve the purpose of choosing between these theories that we've already guessed. It's very rare for us to have more than one explanation for any given phenomena, but where we do, for example, in the case of gravity, we had Newtonian gravity and we had Einstein's general relativity. We needed to craft an experiment, a way of distinguishing between the predictions that these two theories made, and if one of them was inconsistent with that theory, we would say that the observation has refuted that theory, while the other, which is consistent with the observation, the theory which is consistent with the observation, we say has so far gone unrefuted and now remains our best explanation of that given phenomena. And those explanations that we generate have reach. They solve the problem they were created for in the first place, and then go on to do even more. General relativity fixes issues that Newtonian gravity could not solve, but then it reaches into things like the expanding universe and black holes and neutron stars and the GPS system, things that no one imagined 2 centuries ago under the Newtonian gravity framework. My key takeaway from this chapter: is that knowledge creation is a process of guessing what is true and then criticizing those guesses, leading gradually and ideally to the production of good, by which we mean hard to vary, explanations, which cannot be derived from our observations. Chapter 2. Closer to reality. Knowledge brings us closer to understanding reality. This idea of realism is the claim that reality is out there and exists, independent of what we happen to think about it. But our knowledge, what we come to understand of that reality, which is beyond our minds, as well as our minds being a part of that reality, our knowledge of all of this can be objective and should be objective. And that is objective in the sense that no subjective knower needs to be involved in order for the knowledge to actually be knowledge. Knowledge can be recorded in books or stored in computers. It can even appear in objects. The computer on which you are watching this is going to instantiate relationships between the circuits, the knowledge of how to process information. And should all of humanity be wiped out tomorrow, but our artifacts, including our computers, left behind, and an alien race found them, then they could reverse engineer what is going on in the computer and therefore uncover the knowledge that's in the computer by decoding it. And then they would know what we know, what has been stored in the computers. But how is it that knowledge brings us closer to reality? It's interesting because sometimes, in order to come closer to the reality, we need to put multiple objects between us and that reality. For example, returning to trying to understand the nature of stars. In order to better understand what a star is, looking directly at it with an eye that's unaided by any technology is not going to bring you closer to the reality of what that star is. Instead, putting between your eye a telescope and a computer will certainly help in the process of bringing you closer to understanding the reality of stars, putting objects between you and that star. And not only the objects, but also existing explanations can bring you closer to understanding reality as well. You can't see things directly because observation is theory-laden. So when an astronomer puts a telescope between themselves and a star, they have to have an explanation first of how the telescope works. They have to understand whether and to what extent the telescope might be subtly changing the colour of the star, whether there might be artifacts on the lens and so forth. Because after all, once you produce a picture of whatever the telescope is taking using the computer, you might very well end up with something that's on the printed page that is not actually out there in outer space, but it could just be an error introduced by the telescope or the computer processing of the image. This is the sense in which observation is theory-laden. Even something as simple as straightforward looking relies upon a complex process of how light gets through the cornea of our eyes back to the retina, converted from chemical energy into electrical energy, and then finally, somehow or other, translated by our minds into information of a sort. This process of seeing is extremely complicated. But so long as we're correcting errors, then we do come closer to the truth, because this is what knowledge growth really is. It consists of correcting errors and solving problems. Errors in our existing theories. It's people who are the creative entities that do the science and grow explanatory knowledge. People like Thomas Edison and others have said over the years that innovation is very much 99% perspiration and 1% innovation, but in fact that's not true. The perspiration phases of creativity can very much be automated and increasingly are. What's so important now is imagination. The inspiration part, that's all of what science is about. Trying to find a problem and fall in love with it, as Popper says, and then attempting to find a solution, unless of course you find a better problem along the way. So the truth is that in science, it's almost all, or ideally it should be, mainly creativity, imagination. My key takeaway for this chapter is that knowledge growth is about the identification of errors in our existing explanations and correcting them. And sometimes we need to put lots of things like technology such as telescopes and computers, as well as other explanations, between us and those parts of reality we're trying to understand in order to come closer to explaining what's really going on. Chapter 3. The Spark. It is common these days for intellectuals to embrace the so-called principle of mediocrity. That is the claim that people are nothing special. As recently as 2021, the year in which I am recording this, the biggest paid podcast on earth was called Absolutely Mental, and it featured Sam Harris in conversation with the comedian Ricky Gervais. There have been 2 series so far. Now, certainly, of course, it was mainly for entertainment and comedy purposes, but the subtext was, whenever they got into science and philosophy in a serious sense, it really was all about the principle of mediocrity. Over and again, Gervais made the claim, and Harris, if not explicitly, at least tacitly, endorsed the notion that we are nothing special, we humans. There is a continuum between bacteria through to lower mammals and then to us. We are just an incremental increase on what went before. Aren't dolphins and great apes so smart? Look at us. We're just so stupid for polluting, getting in wars and being cruel to other creatures. But this is not merely black comedy. It informs academia as well. Sadly, on this view to some extent, you're an intellectual if you do denigrate people. Only silly religious people think humans are anything special. So this principle says we are nothing special, and also the cosmological principle says that the Earth, planet Earth, is nothing particularly special. It's just a regular planet orbiting a regular star in a rather typical galaxy, one among hundreds of billions of them. But set against all of this is, in the minds of many, a version of what is called Spaceship Earth. Well, these days many people say there is no planet B, even when there are literally many, many planet Bs that have been discovered. Kepler 452b, Kepler 10b, Kepler 442b, take your pick. There are even Cs and Ds and so on. Anyways, no planet B or spaceship Earth says, in fact, the Earth is a special place and nowhere else is. But all of this is wrong. We humans are special, and Earth is only special because we are here. We can make anywhere hospitable. The environment doesn't support us. It is barely suitable for us, as David says. Most places are inhospitable. Even on the Earth, we make the place hospitable, and soon we will make space hospitable. We've already begun. Only creative innovation allows for us to support ourselves here because the cosmos is dangerous, and so is Earth. Enlightenment knowledge is the spark that allows for unbounded progress off into an infinite future. This is explanatory knowledge that allows for the solving of human problems. The only other known type of knowledge in the universe is biological, slow incremental guessing and checking of blind mutations to see if there are any useful adaptations. So the spark is very much us. We people are the catalyst that takes inert, useless material and comes to understand what it is made of. We create knowledge of it, find out what it is, and only then it becomes useful, an actual resource. With this resource, we can begin the process of transforming our environment into something hospitable. And our environment is the universe. Eventually, this ratcheting up of knowledge creation, allowing us to transform physical reality around us, will stretch out beyond the Earth, sparking knowledge creation throughout the solar system, and then the galaxy, and from there, who knows where. The Enlightenment has only just begun to glow in an otherwise implacably dark and hostile universe. Eventually, we can bring the rest of the universe to life by making it hospitable, just as we have done here on a far smaller scale. This is merely the beginning, the kindling of infinite progress. My key takeaway from this chapter is that the Earth is a unique place, so far as we know in the universe, where an open-ended stream of knowledge creation is occurring. However, it will not remain this way, as our Enlightenment traditions will spread to other planets and stars, and one day the rest of the universe. Chapter 4. Creation. Knowledge has to be created. Knowledge being useful information, or information that solves a problem. There are 2 kinds known. The information in the DNA of an organism is useful, so it counts as knowledge. It solves the problem of survival for an organism, ideally, but more precisely, how the gene can spread through a gene pool. And the problem of how to be copied, another feature which makes it knowledge. It appears via the process of evolution by natural selection, as explained originally by Darwin, and which we now know in a so-called neo-Darwinian framework as being about the selection of units on the DNA double helix called genes. Genes, or groups of genes, code for structures in the physical structure of an organism. Mutations of the DNA are, in essence, like guesses about what might work in a given environment. Most are bad guesses and only damage the organism. Rarely, some are mutations which are advantageous and survive into the next generation, as they cause that organism to be more fit in the given environment. They go on to be copied generation after generation. This all looks a little like the growth of explanatory knowledge, where existing ideas can be changed somewhat, but most changes are not good. Knowledge in the DNA and in human minds of the explanatory sort is hard to vary. Small changes will ruin and not improve the knowledge, broadly speaking. That both ideas and genes can be copied and are copied means they are replicators. But there do exist differences. Explanations can be deliberately changed, intelligently designed, if you like, by the free and conscious choices of people who can see a problem and deliberate over it and consider the best knowledge available and imagine into existence new ideas. There is a genuine act of creation on their part, but there is no mind behind the generation of biological knowledge. That is a blind process. And biological knowledge of that sort never does much more than ensuring the survival, or not, of a particular organism or species, while explanatory knowledge has reach. It solves the local problem a scientist, for example, is interested in, only for it then to go on to solve problems elsewhere at different times. The problem of what the structure of the atom is eventually leads to uncovering the cause of radioactivity, and eventually leads to the possibility of generating electricity for hundreds of millions, perhaps even billions of people using nuclear fission reactions. Explanatory knowledge reaches into areas creators of it can never quite imagine initially. Evolution by natural selection replaced Lamarckism. The idea that biological knowledge can be acquired by some sort of process of extrapolation where giraffes' necks got longer because they tried to make their necks longer. Similarly, inductivism assumes that explanatory knowledge is a process of extrapolating from observations. Somehow the knowledge in both cases spontaneously appears out of trends. Both Lamarckism and induction are thus wrong. Evolution by natural selection solved an important problem. That of the problem of the appearance of design. But taking a look at the universe as a whole, the physical laws and the constants there also have the appearance of design. It seems as though the laws have just the right form, and especially the right parameters, those parts of a theory that need to be measured, the constants of nature like the gravitational constant or the charge on an electron, for the universe to be bio-friendly. But the claim that, cosmologically, fine-tuning is solved by a designer suffers from the same flaw as it does in biology. We don't yet have an explanation for the appearance of fine-tuning, but this is only because we do not yet know enough. Whatever the case, we shouldn't be leaping to, it looks like design, therefore it is design, so there must be a designer. That is exactly the same as the error in biological creationism before evolution by natural selection was known. We cannot say why there is an appearance of design in the physical laws, but postulating a cosmological multiverse, or a megaverse, a multiverse of multiverses where the other universes have different laws, doesn't solve the problem either. In truth, this notion is rather too easy to vary, as it could account for any set of laws, including the ones we know to exist in our universe. My key takeaway from this chapter is that both biological organisms and the physical constants in the universe that permit life have the appearance of design. But appearances can be deceiving. Although Darwin solved the problem of why life appears to be designed, the question of why the constants of nature seem to be designed, seem to be fine-tuned, remains unsolved. Chapter 5. The Reality of Abstractions. What happens from one moment to the next in the physical universe is determined by laws of physics acting on fundamental particles. This description of reality happens to explain very little. It is, at best, predictive, but even then in practice, the prediction for large ensembles of particles is intractable, and in principle, there can be no computer so powerful in our universe that it could actually predict what happens moment to moment, precisely because to know what happens next with high precision requires knowing now with high precision where all the particles are and how fast they are moving. But there is no single now because of the relativity of simultaneity. What has this to do with anything at all? This determinism is a form of reductionism where it is assumed, wrongly, that explanations at the lower level are necessarily superior to explanations at the emergent level. But sometimes the emergent explanation, indeed mostly it's the emergent explanation in day-to-day life, is the only known proper explanation. Our go-to example here is the parable of the copper atom, as I've come to call it. It first appeared in The Fabric of Reality, and I've done a number of podcasts on it, including one devoted exclusively to it. But in short, it goes like this. In Parliament Square in London, there stands a statue of Winston Churchill. It's made of bronze, and at the tip of the nose of the statue is a copper atom. Why is that copper atom there? The deterministic predictive explanation goes like this. Matter was produced at the Big Bang, and some of that matter eventually coalesced into stars, and at the core of those stars eventually copper was fused during a supernova explosion. Some of that copper ended up forming the minerals on the Earth, which were mined, and under the action of the forces of the laws of physics, the copper atom eventually ended up at the tip of the nose of Winston Churchill. Now that explanation works for anything, anywhere, anytime. It doesn't matter what the object is, it doesn't matter what the particle is that you're talking about, beginning at the Big Bang, following the trajectories which are determined by the laws of physics, you will end up with the particles being where they are right now. That's predictive. It's not explanatory. A genuine explanation of what's going on is the reason there's a copper atom at the tip of the nose of Winston Churchill's statue is because we make statues out of things like bronze and brass, which contain copper that helps them not corrode away quite so quickly. And the reason the statue is there at all in the first place is because Winston Churchill helped defend the West, the Enlightenment, against fascism. And we like to build statues honouring great leaders like that. And so that's why there is a copper atom at the tip of the statue in Parliament Square. Now, this explanation involves things in its full context of culture and choices and war and things that do not reduce to physical forces and fundamental particles. Things like culture and the choice to go to war involve abstractions, the reality of abstractions. Numbers, and not the numerals that represent them, but numbers are abstractions as well. Anyone can go online and look up now on Wikipedia what the highest presently known prime number is. We happen to know that there is an infinite number of prime numbers, but at any given time, we only know of a particular highest prime number. Now, what is the next highest prime number? We know it exists, but we haven't found it yet. Now, in what sense does it exist? Well, it doesn't exist in physical reality right now. No one's found it. It hasn't actually been transcribed into a computer anywhere. It hasn't been printed on sheets of paper. It doesn't exist in our physical universe. But it exists. It's an abstraction, and it can cause things to actually happen. That prime number actually causes people, human beings, to go out and search for it. So abstractions absolutely exist and can have causal effects on what goes on in physical reality, and it is not reducible just to the action of particles and physical forces. Perhaps the most controversial of all abstractions is this idea of free will. I regard free will as an abstraction. It is just the capacity to choose and sometimes to create knowledge, to freely choose to create knowledge which wasn't there before. But our minds also are abstractions. They are instantiated presently in the neurons within our brains, but there is no reason in principle that whatever is going on in that brain could not be emulated, simulated in the silicon workings of a computer, which means whatever it is not identical to the firings of the neurons in the brain. My key takeaway from this chapter is that non-physical stuff, or rather stuff that is independent of its physical instantiation, in other words, abstractions, can affect physical stuff. It is rarely the case that a description of events in terms of physical interactions is a complete explanation. We often need to invoke really existing abstractions, among the most important of which are ideas. Chapter 6. The jump to universality. It is a jump to universality that really makes the difference between people, by which we mean humans and the possibility of alien intelligence, and perhaps in the future the possibility of artificial general intelligence. It's a jump to universality that makes the difference between these kinds of people and all the other living entities that are out there, those entities that cannot generate explanatory knowledge. We have a kind of universality that is explanatory universality. But what is this thing about a jump to universality? Well, firstly, the first kind of universality to have arisen that we know of seems to have been the DNA code. It is a code which cannot just make some limited number of organisms, but rather can explore the space of all possible carbon-based life. It's a strange kind of thing, DNA. It can code for bacteria and single-celled amoeba and simple life, but also fish and birds, aquatic and air, and land, of course, mammals and so on, and some things in between like amphibians and reptiles. It can do insects and dinosaurs and everything in between those. Basically, if it can be alive and built from amino acids joining together to form proteins, allowing cells to hold water in which are dissolved the chemicals of life, then DNA seems to be able to build it. It's a universal code for life. Human beings have created forms of universality as well. Take ways of communicating. At first, pictograms were used, pictures representing words. This system is not universal because if a new word was invented, then a whole new picture was needed. So the existing system could never represent whatever word or concept was needed when a discovery was made. But our present various systems of alphabets, for example the English alphabet, is universal. Words might get longer, or in some cases shorter, but it's not like we're going to run out of letters or words. And number systems like Roman numerals are cumbersome and not so easy to use to represent large numbers or do complex arithmetic efficiently. But the modern Indian Arabic system of 0 to 9 is universal. It's easy to represent whatever number you like and perform with relative ease calculations in that system. The numbers 0 through to 9 represent any number simply by changing the position of the number. 9 units, 9 tens, 9 trillions, and so on, all with a single digit, and then add a few zeros. It's universal. The most important example in technology of universality is the computer. The Turing machine, a device able to do the work of any other device that computed stuff, was his invention. Including the human mind, by the way, it could do the work of that too. So in principle, the universal computer, the universal Turing machine, could be programmed with intelligence. And then David Deutsch made a further jump to universality with the notion of a quantum computer, a computer that took advantage of the actual known laws of physics, the quantum laws of physics, to allow for quantum computation, a far more efficient way of calculating certain things, importantly, things like quantum systems, which meant that all physical systems could be efficiently simulated by this computer. Provably, that includes human brains. It's not a metaphor that the human brain is a computer. It is the literal truth of the matter given the known laws of physics. All of these computers, quantum or classical, rely on error correction, making them digital devices. The common feature of all these kinds of universality is that they exist in digital systems. But the most important jump to universality in the universe is us, the jump to explanatory universality. Even if other animals can think, and I'm not sure that they can, but if they can, it is about a fixed range of things, whatever is encoded in their genes. But humans, being people, are universal in their capacity to explain the world. This gives us a special relationship with the laws of physics, because what it is in here going on in our minds comes to resemble what is out there over time with increasing fidelity. My key takeaway from this chapter is that many systems gradually improve over time, but sometimes some systems reach a point where there is a sudden increase in capacity such that the system is now able to do everything in some class of tasks. For example, although pre-humans might have been able to explain something about reality, people today can explain everything that is explicable. Chapter 7. Artificial creativity. What is called artificial intelligence is really just an incremental improvement on the kinds of tasks computers have always done, calculating, extrapolating, and doing very little that is surprising. A program that is created to learn to play computer games does exactly that. It does not tend to stop and decide to write a poem on a word processor. Computers presently do precisely as they are programmed to do. They do not disobey, but people disobey. Creativity requires disobedience, to go against what was known or acceptable before. What this tells us is that the programs running on these computers do not create anything new, only the programmers do. A computer that beats a chess grandmaster is impressive, but it is impressive because of raw power and clever programming. It is not creating new knowledge, it is literally calculating among known possibilities. It is not having fun, and it is not ever able to do anything else other than that one thing. Even a computer programmed with a wide repertoire of abilities is not approaching universality of the explanatory kind. Universality of that kind, actual creativity, actual artificial general intelligence, intelligence like ours, has no fixed repertoire. We can invent new tasks, unlike a computer. We have problem situations. Likewise, evolutionary algorithms are not examples of actual evolution being simulated either. A PhD student who designs a robot with legs, or even just simulates one, which then goes on to learn to walk through trial and error, has been given a fixed task: learn to walk. And it has a criteria for learning to walk, so it is unsurprising that it manages to achieve this modest task eventually. But if it then begins to dance a waltz without ever being programmed, that would be a truly impressive display of evolution. And if it ever then went on to invent beautiful new dances no one had ever seen before, then we should all think we are in the presence of an actual artificial intelligence, an AGI, a person. Until then, all we have are dumb computers. Impressive. A Tesla car is impressive, but it's not intelligent. When a programmer writes a so-called evolutionary algorithm, the thing is, they are putting their explanatory knowledge into the code, and some of that knowledge has reach. What this means is that the knowledge itself ends up being able to solve problems the programmer might not have thought of. But this does not mean the code or the knowledge, and certainly not the robot, is actually thinking of those problems. It just means that the problem is encountered and the code was already a solution for that problem. There's a thought experiment in this chapter which basically goes, a true evolutionary algorithm, if it is to replicate evolution by natural selection, which, recall, is an iterative process of random mutations, the random being important here. Anyways, an actual evolutionary algorithm would not begin with the knowledge of the programmer. It would begin with almost no knowledge. So if we took, say, a robot that could walk, replace its program by a sequence of random numbers, and then have a random number generator introduce more random numbers each time the program is run, and you keep the same criteria in the program for succeeding as in any usual evolutionary algorithm, if after some years of doing this, the robot ends up walking at all, then we've refuted the idea that in those other programs, it was all just the programmer's knowledge achieving the task after all, and not evolution. Evolution is, after all, blind, and the mutations are random. This thought experiment also points to the fact we do not understand how actual evolution by natural selection works in very fine detail either. We know there has been a ramping up of complexity in some species over time. We cannot say precisely why, because our existing understanding of the theory says that evolution is blind. And as always, the maxim, if you can't program it, you haven't understood it, holds. In both cases, evolutionary creativity and explanatory creativity, we do not understand how to program a computer to simulate either of them, which would be to actually create a version of either. And at least in part, this is because we do not understand how universality in either of these cases is operating and represented in the DNA or the human mind, respectively. My key takeaway from this chapter is, if you can't program it, you haven't understood it. And we can program neither the ability to simulate the creation of biological knowledge, nor of explanatory knowledge using our computers. Indeed, first we're going to need algorithms for both to be constructed before we can begin to think about actually writing some code. Chapter 8. A window on infinity. Mathematical infinities can produce some seeming paradoxes. David Hilbert imagined an infinity hotel to push our intuitions about infinity around. If you consider a hotel with an infinite number of rooms and all of them are full, then you might think that, well, if they're all full, there's no room for more patrons. But let's think a little more carefully. Unlike with a regular finite hotel, if Infinity Hotel is full, it doesn't actually mean there's no more room. For example, if another guest does arrive, all the management need to do is to announce via the PA system that everyone should move to the next highest numbered room. So the person in room 1 moves to room 2, the person in room 2 moves to room 3, and so on. That would leave room number 1 unoccupied. There is no last room, so it's not a problem what actually goes on there. However, Infinity Hotel can be overwhelmed. This is because room numbering in Infinity Hotel consists of countable room numbers. You can literally count them, 1, 2, 3, 4, and so on. But some infinities are uncountable. It was Georg Cantor who proved, using a diagonal argument, how some infinities are larger than others. The way a diagonal argument works is this. Imagine the rooms at Infinity Hotel were assigned one of the decimal numbers between 0 and 1. There are clearly an infinite number of those. Would we be able to assign one decimal number identically to one of the hotel rooms? Imagine we did this at random. So room 1 got assigned to the number 0.5567, and that goes on forever. That ellipse there, the 3 dots, means the number continues without end. Imagine room 2 is 0.542. Imagine room 3 is 0.971, 4 is 0.509, and you keep on doing this for all the rooms in the hotel. Would any decimals be left over? Would some ever go unassigned? What about this number? Let's construct it by differing from the number assigned to room number 1 by the first digit. So instead of it being 0.5, let's take the 5 and we'll change it to a 6, but you could pick any number that you like. So far we've got 0.6. And let's say it differs from the second number by the second digit in some way. So instead of 0.54, so instead of the 4 in that second place, we will take that and change it into a 2 arbitrarily. And in the third number, we take the third digit and we change that, and so on, for all of the numbers assigned to the rooms of the hotel. By the end of this process, you will have constructed a number different from any of the numbers assigned to any of the rooms in the hotel. And so there would be a decimal number that appears between 0 and 1 that is unassigned to any room in the hotel by definition. This is a diagonal argument, and you've produced there a proof of an uncountable infinity, a kind of infinity that includes numbers not in the infinite sequence that you might otherwise think contains all the possible numbers. And the curious thing is about counting integers is that no matter where you start, you're always unusually close to the beginning because you're always infinitely far from the end. There is no end after all. You're infinitely far from infinity. And in physical reality, we like to say we're here at the beginning of infinity, and we'll always be at the beginning of infinity and unusually close to it. That's what infinity just happens to be like. We live in a multiverse where we actually can't count the universes. There might be uncountably infinite numbers of universes and therefore copies of each of us that differentiate into infinitely many copies over time. And we, as the knowledge creators in physical reality, only know something of whether a thing is true or false because the laws of physics allow us to do the knowing, the proving or the calculating or explaining that is possible to do given the physical brains that we have. It is therefore physics that underpins what it is possible for us to claim to know, including claim to prove in mathematics. That some mathematical theorem is true or false may be independent of physics, but our fallible human knowledge of that theorem is not independent of physics, but bound by it. After all, our brains are physical objects. Proof and explanation are physical processes. My key takeaway from this chapter is that we are always at the beginning of infinity, so we are still unusually primitive compared to people of the distant future. We are thus lucky compared to our ancestors, but terribly unlucky compared to our descendants. Chapter 9. Optimism. All evils are caused by insufficient knowledge. This is what David Deutsch has called the principle of optimism. To some extent, it is a special case of problems are soluble. Unless there is a physical law preventing us from solving the problem, then the problem can be solved by creating the knowledge needed to solve that problem. Among all the categories of different problems that exist, evil is one kind. Not all problems cause suffering or evil, only some do. Some problems are fun and lead to no harm at all. The problem of how to improve the CGI in a movie is not an evil, but it's a soluble problem and fun for some to try and figure out a solution to. But problems which do cause suffering, evils, are due to our not knowing how to fix that problem. Yes, serial killers are an evil, but so are earthquakes and cyclones. If we knew how to prevent all murder, we would do so, but we don't know how. And the same is true of any other natural disaster. And people do evil things because they don't know better. Morally, they do not know what the right thing is. Even if they claim they do know what the right thing is and choose to do otherwise, this is still an example of a lack of knowledge, a lack of actual moral knowledge, which would have directed their behaviour towards something better, something they should have done. In morality, as in physics or mathematics, it is possible to make objective progress. With morality considered as that domain concerned with what to do or what to do next or what you should do, there is something objectively better and something objectively worse in the choices before you. And in the limit, there must be something like an optimal choice to make given the values of any particular person. And those values are themselves claims about what is right. And they could possibly be wrong, and so they can be improved. All of this means that in morality, as in physics, it is possible to be wrong. And because there is something to be objectively wrong about, there are true and false claims we can make in these areas. What we need to do everywhere is to seek out good explanations, as there will never come a time where in any domain our knowledge is anything like complete. There can be no end of science and no end of progress. Fallibilism is the claim that we might be wrong about something, and this is an optimistic way of viewing the world because the capacity to be wrong means the capacity to error correct, and hence the possibility of making objective progress. And that is always our circumstance. At the level of society, we want an open and dynamic society, one that has a tradition of criticism. A tradition of criticism means we take nothing for granted and attempt to objectively improve our best explanations over time by incremental means. The key thing here is error correction, identifying errors where we can find them and conjecturing ways to correct those errors. What is important for our civilization is to continue to preserve the means of error correction. Our society, the civilization that continues the Enlightenment tradition, has been especially long-lived and uniquely long-lived, in fact. Preserving error correction means preserving our civilization because that means preserving progress and problem solving. For almost all of geological history on this planet, whenever an asteroid was on a collision course with Earth, it struck this planet. For the first time ever, our planet is in the unique position in the universe, so far as we know, where asteroids will be repelled by a planet. Our planet, in the form of our technology, created through our knowledgeable use of resources. So whenever anyone says that the chance of civilization being destroyed by an asteroid is 1 in 10,000 in the next 100 years, what they mean is completely absent human knowledge and choices. We cannot prophesy the future with any reliability because we cannot predict what people will choose to do in the future. And especially, we cannot predict what knowledge they will have created. This is as true for climate change and viruses as it is for asteroids. It is never a matter of probability, but knowledge. Problems are soluble. My key takeaway from this chapter is that all evils are due to a lack of knowledge. If we continue to create the wealth needed to fund the solutions to solve our problems, we will be in the best position to prepare for the unknown problems of tomorrow. Chapter 10. A Dream of Socrates. In this chapter, David explains epistemology, what knowledge is and how we create it, through a dialogue largely between the god Hermes and Socrates. In this chapter we find that all knowledge is conjectural, it is guessed. But that doesn't stop it from being objective. It tracks reality and is independent of what anyone believes to be true about that knowledge. And so knowledge is not what the ancients say, a form of justified true belief. After all, the standard of justifying as true is impossibly high to begin with. And as for believing knowledge, well, there are many instances where not only would this not be desired, it would be absurd. It would be wrong to believe as true a flat Earth, but constructing the concrete base of your home on the assumption that the ground there is ideally flat is a reasonable one. But you don't need to believe that. I also don't need to believe Newton's law of gravity. I know it, it's part of my knowledge, but there's no possible way I can justify it to be true. Indeed, I know it to be false. Yet, it is knowledge. It solves a problem. We cannot see what is before our eyes. That we can, or that we should endorse the claim that seeing is believing, ignores most of what is interesting in science and elsewhere. I cannot see the atoms before my eyes. I cannot see the oxygen in the air that I breathe. Yet I know about atoms and I know about oxygen. Knowledge is not primarily about the information our senses provide us with. In fact, it is more about correcting the errors in the misconceptions our senses naively lead us into. Our senses lead us astray all the time. Indeed, our thinking can, and anything, therefore, can be doubted. Just because we cannot think of a misconception right now about a piece of knowledge that we have does not mean that piece of knowledge is once and for all finally true. It may just mean we have a lack of imagination. Consider the claim that through any 2 points a unique straight line can be drawn. This is not actually true. Look into that a little, perhaps here. Whatever the case, it might be that there is just one central moral maxim. That is, the moral maxim that brings morality, to some extent, within the sphere of epistemology. The one thing we should never do. We should never destroy the means of error correction. This idea of should, that's a moral claim. This idea of error correction, that's epistemology. And further, our latest understanding, coming from constructor theory, is we might also say that what is possible to error correct, and ultimately how physically to correct an error, is a matter of physics. And this is pure speculation on my part, but in a distant future, might there be a physics of morality? What I am not trying to say is that we will ever be able to determine by some calculation what to do morally, but what I do mean is that perhaps physics itself will place limits upon us morally, even if it cannot tell us what to do. It will say perhaps what is impossible amongst all of our shoulds. But this is beyond the scope of this chapter, so I'm cheating a little bit. The chapter here also contains a perspective on the so-called Socratic problem, the problem of what Socrates, the philosopher, really said or thought. What we know of Socrates comes to us filtered through the writings of Plato. And while Socrates seems in some moods to be a fallibilist, Plato wasn't. Plato was a genius, of course, but also all sorts of wrong on epistemology and political philosophy and morality and mathematics and so on. So it may be that he simply misunderstood Socrates, his teacher. Misunderstanding is the natural state of affairs, of course. As Popper admonished, it is impossible to speak in such a way as to not be misunderstood. In this chapter, David also makes some remarks about the nature of philosophy compared to other academic disciplines. In philosophy, as it appears in universities, there's rather a lot of attention paid to the history of philosophy, what this or that ancient or classical philosopher actually said or meant. It should perhaps be more like physics or chemistry or science broadly, where we almost never consult the original source of some idea or theory. Instead, we just take the idea itself for granted and then make some progress. My key takeaway from this chapter is that knowledge is not derived from the senses. It is we people who create it in our minds by a process of guesswork. We guess what is true and criticize those guesses in the light of our observations and other kinds of refutation. The purpose of observation is to decide between theories already guessed. Chapter 11. The Multiverse. The experiments in quantum theory can only be properly explained by recourse to a physical reality that is stupendously larger than the one we observe. This continues that tradition in science that the size of the reality we inhabit seems to only ever be going in one direction, getting bigger and bigger to include more and more stuff that we don't ever hope to directly observe. To explain the motion of particles we do see in our universe, we need to invoke the existence of entities we do not see. These other entities are behaving like fundamental particles, which means they are fundamental particles, because they affect the fundamental particles we can see. This stupendously larger ensemble of entities, beyond what we can see, we call the multiverse. There are many experiments that are used to illustrate this reality. One is known as the Mach-Zehnder interferometer. Here, 2 half-silvered mirrors are placed with 2 regular mirrors. The half-silvered mirrors allow photons, particles of light, to either go through, be transmitted, or bounce off, be reflected. At the first mirror, we cannot predict in our universe whether a given photon will be transmitted or reflected. We can only say that it's got a 50% chance of either. At the second half-silvered mirror at the end of the experiment, what happens is that the photon is always detected at the arrow that says photon out, and never at the nothing out arrow. But why? Why isn't it 50-50 here as well as it was in the first mirror? The reason is that in truth, at the first mirror, what happens is that the photon that interacts with that mirror is a multiversal object. That means it occupies many universes. We are in one universe or one group of universes, so can only detect it either going along X or Y, even though in truth it does go along both. We know this is true because only if that photon takes both paths, the one we see and the one we do not see, can we explain how the two photons interfere at the second mirror and recombine there, causing it to always go in only one of those directions rather than both. This is the only explanation. Something is interfering with the photon at the second mirror, and that something is its counterpart in the other universe. If we did not live in a multiverse, if our universe did not consist of many things that we do not observe, we should expect a 50-50 split as at the first mirror. What is happening at that first mirror is that the photon differentiates into two groups, and thus so do the universes and the observers in those universes. This is going on all the time. All objects we can see are multiversal objects. They exist in the universe we observe, and many others we do not, sometimes with slight or even very great variations. And the truth is deeper still. What we observe is a universe, but it is a universe of objects that have fungible instances. Perfectly identical instances in the same place at the same time that occupy different universes. So they are different in that sense because they could potentially partition themselves into universes which cease to be fungible. The theory of quantum computation requires that a multiverse exists because it is otherwise impossible to explain what quantum computers are in principle, and one day will be in practice, capable of doing. Namely, a quantum computer would be able to perform calculations that a computer, even the size of our entire universe, could not possibly do. And it can only do this because it, the quantum computer, can take advantage of computing power in other universes using interference. We cannot explain how a quantum computer does what it does in retrospect by appealing to a single classical history. We have to invoke once more the existence of histories we observers did not occupy. This again is testament to physical reality being more than just a single classical universe, and as unpalatable as it might be to some people, this means we're in a multiverse. Many semi-parallel, at times barely interacting and sometimes not interacting, universes. A person, on this view, in the multiverse, is a channel of information flow along which knowledge grows. This is unique in the universe, and this knowledge may turn out to be among some of the longest persisting structures in the multiverse. For more on all of this, see my now 7-part and indeed more than 7 hours series on the multiverse right here. And see also this, the Nexus video, for more on what the philosophy of people and the philosophy of self might be in the multiverse. My key takeaway here is that the physical universe is stupendously larger than what we can ever hope to observe. We call the approximately autonomous regions closed off from us other universes, and together with our own universe, we call the entire ensemble the multiverse. Chapter 12. A Physicist's History of Bad Philosophy. A reason why the Everett or quantum multiverse is not more widely known, taught, or even taken seriously by actual practicing quantum physicists is bad philosophy. There was a retreat into some sort of relativism and instrumentalism by physicists in the early 20th century. Instrumentalism is a fancy word for this idea of shut up and calculate. It is the idea that science, properly considered, is simply about being able to predict the outcome of experiments rather than actually understand and hence be able to explain what is really going on in reality. Anyways, this chapter is about how the equations of quantum theory describe particles as seeming to be in multiple places simultaneously and having multiple velocities simultaneously. So to take the theory and the formalism literally as a description of reality, particles do have those properties. However, when you go to observe any single particle, we find it in a single place. So how do we square this? The theory is saying one thing, the particle has multiple positions at the same time, and our observation, the particle only has one position at a time. Well, if you're a physicist struggling to understand all this in the early 20th century, you may well throw your hands up in the air and say all the possibilities, except for the one we observe, collapse or disappear upon the act of observation. This seems to put the observer, the act of observation, right in the centre of fundamental physics. Observation is doing something fundamental to the physical theory, and that has led to all sorts of nonsense claims ever since being made about quantum theory, bringing in consciousness and mind to the quantum realm. This idea that observation destroys all the positions a particle was occupying, except for one, is known as the measurement problem. How it actually happened, no one could say, and people gave up for a time trying to really find out. They just accepted it. All of this was, at least in large part, motivated by bad philosophy. This is philosophy that's not merely false, but it actively prevents the growth of knowledge. The idea that science should only be about predicting the outcome of experiments acts to prevent us from improving actual explanations of reality. After all, it rules out explanation as even being a part of science in the first place. But bad philosophy has not only affected physics, it's also infected some other sciences, or what should be sciences, like psychology. Behaviorism in psychology is instrumentalism as applied to that subject, and says that because we cannot directly observe minds, we can only observe human behaviour and trends in human behaviour, then this serves as a proxy for understanding why people do what they do. This denies ever having good explanations of the human mind. Consider that an antidepressant may make a person objectively happier, or it may simply lower their standards for what they think of as happiness. Presently, there is no good explanation and no experiment that can distinguish these two possibilities. Happiness could be a state of continually solving your problems, and when you are constantly thwarted in solving your problems, then your happiness turns to unhappiness. But behaviorism looks at behaviours, including people's self-reporting, that's a behaviour, talking, that indicate more or less happiness without ever wondering what the causal link between what is actually going on in the mind in terms of thoughts and ideas and what causes behaviours. We call this explanationless science. It might all look like real science is going on, experiments might be done, papers written, graphs with trend lines produced, but if we cannot ever say why something or other constitutes happiness in the first place, if we do not have an explanation of what a particular mental state is at the level of ideas in the mind, then we cannot hope to maximize it, let alone treat deficiencies of it. Bad philosophy continues through to today. Relativism is a form of bad philosophy that denies the possibility of objective knowledge and objective truth. It really took off soon after Wittgenstein published his major works. Wittgenstein thought most of philosophy reduced to puzzles, and it was all just about language that people were using rather than actual philosophical problems. Wittgenstein is still extremely popular today. Many people think that philosophy is just about argumentation rather than solving particular philosophical problems. Reducing every single problem to nothing but a puzzle in language is quite a dangerous route to go down, and it breeds a form of relativism, which we inherit today in certain kinds of wokeism. My key idea from this chapter is that instrumentalism is the idea that the purpose of science is to predict the outcome of experiments. This constitutes a kind of bad philosophy, which we define as philosophy which actively prevents the growth of knowledge by denying reality or truth or the possibility of finding good explanations. Chapter 13. Choices. When people have a choice before them, it is often not a case that pure logic and therefore any mathematical process of objectively weighing options is going to lead them to the best choice. Instead, what people actually do, both individually and even when acting as part of a group, is to creatively conjecture new options no one had on the table before. So it cannot be a process of weighing existing options because the existing options can always be changed. Social choice theory is an attempt to turn decision-making by people into a purely logical exercise, to make it perfectly rational. The motivation, I suppose, was a noble one. Take out the messy emotions and subjective feelings from the issue and look simply at the facts and apply some rigorous, rational, mathematical framework to the situation and see which choice is actually calculated to be best. The problem with this is that all such schemes for trying to turn decision-making into a branch of mathematics encounters what are known as no-go theorems, paradoxes, and things that are simply illogical. One of the most famous of these discussed in the book is known as Arrow's theorem. This theorem is about how a group might come to a consensus. Arrow begins with a set of axioms that any such group would want to adhere to if they're going to make a rational choice. These uncontroversial axioms, the starting points, would be things like, well, if a group is going to be unanimous on a particular decision, then that decision should be whatever the unanimous vote happens to be. Logical. Another axiom is called the no dictator axiom. One person cannot be said to represent the whole group unless everyone already agrees. And consult the book for the others or look up Arrow's theorem. These axioms are completely uncontroversial. You'd want to be able to agree with them. Here's the problem. What Arrow showed is that the uncontroversial axioms, despite being perfectly reasonable, are also inconsistent logically with one another. In other words, they cannot all be satisfied simultaneously. This is a deep problem, a fatal blow to the idea that decision-making can always be a perfectly logical exercise. So what do? Do we just give up on logic? No. What we do in these cases, whether individually or as a group, is to create new options and have a good explanation either for some existing option or the new one. We then choose among our options by choosing among the explanations and criticising and hence refuting the other options. This is actually how decision-making works. It's not a process of weighing, but criticising. Truly objective decision-making more resembles objective science. We have some theories or policies at the level of society and we seek to refute all of them, except for one, ideally. And that one that goes unrefuted, that survives the critical process, that's the one we accept as our best explanation or as our best policy. Or if none of them happen to be satisfactory, what do? We use our creativity as people to invent a better theory or policy. Democracies are systems of government for making decisions. But the quality of a democracy is to be judged not by whether the best ruler is installed and to what extent. This is isomorphic with the error that science is about finding the once and for all true theory. Instead, what democracy is a system for removing rulers and policies easily, without violence. That is the standard by which we judge democracy and its institutions broadly. This also means that the plurality voting system is the best system of voting, because it means a ruler can be more easily removed if they're a bad ruler. This is unlike in any preferential voting system, where that bad ruler can form a coalition and get preferences to keep themselves in power. The more parties there are, the more coalitions can form, and this means deals are done to keep themselves in power, even when the voters no longer want those elected officials in office. Politicians like preferential voting systems for this reason. And on this point, compromise has an undeservedly good reputation. What a compromise is a theory or a policy that wasn't anyone's first choice in the first place. So when it fails, as inevitably it often will, everyone involved in the compromise can turn around and say, well, that's not what I ever wanted anyway, and therefore no one actually learns anything when the compromise fails. My key takeaway from this chapter is that making a choice is about choosing the best explanation. When there are options before you, the only rational thing to do is to criticise them in the hope that all but one of them are refuted. If none are satisfactory, then we use our creativity to come up with a better option. And unless there's a threat of violence, don't compromise. Chapter 14. Why are flowers beautiful? Aesthetics, art, music and beauty are all domains of objective knowledge. Yes, people have subjective preferences, no one denies this, but this is not to say that there is no such thing as one particular thing, in truth, in reality, actually being more beautiful than another. There are objective differences, not merely between noise and music, but between music of different epochs, the proverbial cave people banging on drums and modern music today. or cave art and modern 3D computer-generated art. Cave people would have liked to know how to paint better, and there really is a better. They would like to have made objective progress in their art and storytelling. The waste paper basket, as we like to say, of the musician and the composer fills up over time because they are trying to reach an objective standard, trying to make something sound better, and not merely to them, but to everyone. And in actual truth, some sounds simply are more harmonious, more beautiful than other combinations of sounds. The fact that today we cannot rank order all musicians that have ever existed from worst to best in a way that everyone would agree with does not mean there are no objective standards. It just means that we don't know much about those objective standards yet, and those standards are sometimes swamped by, yes, the subjective taste of people. But the existence of subjective taste does not rule out the existence of real objective standards in music and elsewhere in art and aesthetics. Beauty, if we think of it as attractiveness, is something humans have tried to produce and surround themselves with since time immemorial. An art piece is objectively beautiful because people are attracted to it by the measure that people return to it over and over again in the gallery. Not all of what is called art does this. Some art rejects the notion of beauty altogether and exists rather to provoke or make a political point. But again, this rejection of beauty is likewise no proof that objective beauty and the capacity for something to be more or less attractive does not exist. The existence of creationism doesn't show that there's a problem with evolution by natural selection. Likewise, the Museum of Modern Art with its Duchamp urinals doesn't prove that the classical art gallery does not contain objectively better art. Flowers are attractive. Insects are attracted to flowers. But so are people. Whatever it is that flowers are doing in creating beauty in nature, it acts to attract both insects and people. Something needs to be explained here. There must be some objective standard of beauty operating, even if we cannot in fine detail say exactly what it is. But it seems to be the case that flowers are beautiful because they needed a way to signal across diverse species. Insects co-evolved with flowers, and so the flowers evolved to be beautiful. And we humans seek out objective beauty also. So we find flowers beautiful because they are actually in reality beautiful. It's not just our opinion. Evolution designed them that way to attract insects. People enjoy objective beauty because we are trying to signal across the wide gap between us and other humans. Between one human person and another, there is a vast gap in preferences and knowledge and more besides. The differences between one person and another are like the differences between species. So if we are to signal to one another what we like, we will learn to appreciate objective beauty too, and so we will create things more and more beautiful. This signaling to one another and attracting one another to our creative output is what we're all about. The best way to do this is by finding those objective standards of beauty, just as flowers did. My key takeaway from this chapter? There is a parochial kind of beauty. We've all got our own tastes and preferences, yes, but there are also objective standards for beauty, some of which have evolved in flowers, and many of which we have only just begun to discover through our creative and artistic endeavours. Chapter 15. The Evolution of Culture. This chapter contains some really new and deep insights about memes. The concept of a meme was invented by Richard Dawkins and is the abstract analogue of a gene. In other words, it's a replicator of a kind. It contains knowledge, certainly information, and can be combined in complex ways to direct behaviour. Moreover, memes evolve. In short, memes are a kind of idea that persists but may also change gradually over time. Cultures consist of many memes. And Deutsch's deep insight in this chapter is that there are important differences between cultures in terms of their memes. Deutsch refines this notion to be about dynamic and static societies. Why is it that so many societies have gone extinct, especially given that the brains of people in the past were anatomically almost indistinguishable from the ones we have today? Those primitive people, had the capacity to be creative. So why weren't they? Well, because they used their creativity to keep things the same, something that I'll return to in the next chapter. ideas that people have which tend to keep a society the same, or in other words, actively prevent the growth of knowledge, are called anti-rational memes. These are not merely irrational ideas, which might be thought of as bad ideas, but rather anti-rational memes are the ones which say, you may not criticize this thing. They disable the person's critical faculties. So you can imagine all sorts of evil notions like those that say, if you do raise an objection to anything in this holy book, you can be put to death. This acts to prevent anyone from criticizing the holy book, and in time it stops them even being able to think of criticisms. It is an anti-rational meme, and it can get replicated as parents teach their children that, and their children teach their children, and so on. But a rational meme is one which relies on a person's critical faculties to get itself replicated in the first place. A person tries to criticize the idea, but fails to find any valid criticism, and so they pass it on because they think, that's a good idea. Implicitly they think, I couldn't refute it, so I'm going to regard this as part of my knowledge and I'm going to spread it out into the world. Theories in science are like this, so are musical tunes and jokes. The underlying idea gets passed on, even if it's not verbatim. A culture is a set of ideas or memes that cause the people in that culture to behave in more or less similar ways, but there is an important way to distinguish between two extreme kinds of society. The two extremes are a static society. This is the one that is ruled by anti-rational memes for the most part. In such a society, centuries and millennia can pass and almost nothing changes. But a dynamic society, a society like ours, is ruled by rational memes, where the anti-rational memes have not quite been eliminated, but minimized to a large extent. It is one where the thing that stays the same is change. The Enlightenment is the longest surviving example of a society where it is dynamic because there exists this overarching anti-rational meme. A rational meme, in other words, but a special kind of rational meme that guards against the anti-rational kind. And that meme is the traditions of criticism, or the tradition of criticism, if you like. The underlying idea of which is this: it's all up for grabs, and you can criticize anything. Free speech and institutions protecting free speech, and more besides, to protect the means of progress. Now, there is no perfect example of either a static society, something that really doesn't change at all over time. Even the near-static societies do change, but very, very gradually. And even our culture is not a perfect example of a dynamic society. There are threats even now that slow down progress. The creeping wokeism and so on, and kinds of political correctness that cause people to not criticize ideas for fear of offending someone or suffering legal action. But in the main, our society is a very robust and good example of a dynamic society. We are the best society to have ever existed. Primitive societies were unimaginably bad. We are always at the beginning of infinity, so even our society is transitioning, and because of creativity, which is error-prone, we will always be transitioning to something even more dynamic. My key takeaway from this chapter? Dynamic societies like ours value criticism and protect our ability to correct errors in our ideas through the propagation of rational memes. This stands in stark contrast to static societies where anti-rational memes have taken hold, disable their holders' critical faculties, and make people reluctant to criticize and therefore improve existing ideas in the culture. Chapter 16. The evolution of creativity. Humans are creative entities. Our defining feature is that we can create explanatory knowledge. Any other people in the universe, be they aliens or artificial general intelligence, will be able to explain their environment. So why is it then that for most of human history, most humans living in primitive societies failed to do much good explaining? Hence, why did they fail to make much progress? The Enlightenment began around 1700 or maybe a little bit before, and the Industrial Revolution began to happen just a little bit later than that. But why did neither of these things happen 1,000 or even 10,000 years earlier if people had the same capacity for thinking and creativity as the people then did and the people today have? The answer is that the creativity they did have was being used to keep things static, the same and unchanging. In a static society, the way to stand out as a good person and get a mate or get respect or gain authority and so on would be to enact the memes of that society, the culture, ever more strictly, to be especially static in your outlook, to be especially obedient and uncreative. The replication of a meme takes creativity. It cannot be copied directly because we do not have direct access to each other's minds. And what we do when we copy a meme, or rather replicate it, is to replicate its meaning. That's the whole content of a meme, its meaning. Some thinkers on the topic, for example, the wonderful Susan Blackmore, who has popularized the field of memetics as much as anyone, has suggested meme replication occurs by imitation. But David Deutsch explains that this is not possible because we do not have direct access to the memes, the ideas in people's minds or brains in order to do this. Instead, what actually happens is we observe behavior and we don't directly copy that either. It certainly looks as if we are copying, but it can't be that. After all, let's imagine a simple example, a child learning to wave back at someone. If it was all about copying that behavior, would that mean going to stand where the other person is and wave from that exact location back towards where the child was previously standing? Would it mean the child getting a stool and standing on it so their hand is the same height as the person waving at them? Would it mean putting a little bit of artificial hair on their arm so their arm was being copied somewhat more faithfully from the adult? What exactly is being copied or imitated in this situation? Well, David relates the story of how Popper would begin his lectures on the philosophy of science with one word. He'd say to the students, observe, and then just wait. Eventually, one of them would ask what they were supposed to be observing. Well, exactly. You need a theory first of what to observe and how before you can begin observing. This was perhaps one of Popper's deepest insights. Observation is theory-laden, and so when we are trying to replicate a meme, we have to come at that situation with a theory to begin with. David imports this whole notion into the field of memetics. It cannot be straightforward imitation of behaviour or copying. No, rather the child or anyone else seeking to uncover what someone else is thinking, to replicate their meme, so to speak, has to guess what is true and wait for feedback from the world. A child might very well, upon being waved at, run over towards a person and need to be corrected at some point by a parent who helps them learn. Now, you don't need to run over there when someone waves at you. You can just stand here and move your hand or something like that. Anyway, the child guesses what is correct and eventually they get it. Apes and parrots can ape and parrot, but they cannot construct knowledge like humans can. Although they've got memes, the repertoire of their memes is fixed by their genes, but their brains are sufficiently evolved so that they can change the sequence of the memes that are fixed in many different ways. It's rather like they've got 100 pieces of a puzzle which can be arranged in perhaps thousands of different ways to do different things. So from the outside, it kind of looks a little like they're creating knowledge. However, the repertoire is fixed. The number of possible combinations is fixed. This explanation for how lower animals, like apes, imitate behaviors like sounds and even sign language is called behavior passing. And so it kind of looks like what we're doing, our thinking, our creativity. It was discovered by the animal behavior theorist Richard Byrne, and it requires no actual creativity on the part of the ape or the parrot of the explanatory type. But humans are different. We invent new puzzle pieces all the time, and so our repertoire of possible behaviours is unbounded. It is not fixed by genetics. We flew that coop long ago. Now most evolution goes on outside the genes. Genetic evolution was just a prelude. Most of the rest of the history of evolution in our universe will be about the evolution of memes. My key takeaway from this chapter is that for most of human history, people were using their creativity in order to simply keep things the same. And they were doing this because the way to be more accepted in a static society is to be more conformist, to be more obedient. But in a dynamic society, the way to stand out is to innovate and to be creative. Chapter 17, Unsustainable. Static societies reveal an important truth. If criticism is not valued by a society, it will go extinct. The parable of the Easter Islanders is salient here. They built great monuments for no more purpose than appeasing their superstitions. As whatever tragedy, disease or famine or some other natural disaster befell them, the rate of their monument building increased. They failed to try something new, to criticize the way things were done. So they went extinct. Over and over again, lost civilizations are testament to not solving their problems in time. We are unique because we value criticism, but it is a tradition of criticism, and so we have to be careful that the institutions that preserve that tradition likewise are protected. So we are making progress fast and slow, in fits and starts, and it has been unrelenting for a time, but it's not inevitable. We need resources to build it, energy to fuel it. David Attenborough and other naturalists have gifted the world with a deep misconception over many decades now. And that misconception is that something like the tragedy of Easter Island is an example of their having consumed the resources there in an unsustainable way. But this is false. It is false because the island could never sustain them in the first place. The island was always a death trap. It had not enough trees that grew not fast enough. It had insufficient arable land, too little drinking water. Storms hit them, drought hit them. What they had of crops routinely destroyed by weather or pests. Bacteria and worse got into their water supply when it did rain. It was a hellhole. And if they knew how to sail elsewhere to somewhere with more resources, more pleasant, they would have done so. Or if they knew how to use the resources already there, perhaps more importantly, they would have survived. Nothing is a resource, after all, until the knowledge of how to use it as such is discovered. Resources are plentiful. The Earth cannot sustain us into the indefinite future. The lesson of Easter Island is that we need to make progress faster. We need more energy, and cheap energy, not less. We should be optimistic that problems are soluble. There are many, many problems ahead of us. Climate change is one of them. If we want to survive it, or whatever we eventually will discover is way worse than climate change, we must have more wealth. Wealth we define as the repertoire of physical transformations we are capable of making. To have more wealth, we should be seeking out more and cheaper resources and exploiting them. If we have insufficient wealth, when the proverbial asteroid or even worse virus eventually does arrive, we will not be sustained by anything else but our wealth. All we've got is our knowledge. That unique capacity that the laws of physics allows in us to understand anything out there in the universe and thus solve any problem we try to. Throughout the decades, people have drawn incorrect guesses about the future, which we call prophecies, that suggest doom is coming. They say the world is entering a new ice age. Presently, we are told we are entering a period of warming. While we should take seriously the explanations of the experts on these matters when they are brought to us, we should also keep in mind that slowing progress and reducing wealth by concentrating it in the hands of authorities is not a solution. It does not create rapid knowledge growth and progress. To solve a problem, we need knowledge, and that knowledge could come from anywhere. It could come from a child presently struggling to learn to read in an impoverished country somewhere, if only they had very cheap electricity and semiconductors. That child could be interacting on the web with people learning to read far more rapidly and eventually learning the physics needed for him or her to solve the problem of climate change quickly and efficiently. Perhaps by uncovering what it takes to make electricity from fusion reactors more cheaply. We cannot know that this is not the case. Who knows what resources are yet to be discovered and which will make many of our present political discussions moot in light of a new fuel source or way to suck carbon dioxide out of the atmosphere. It was once said that the only way for a colour television to work was with phosphors, and the red phosphor required europium. Supplies were finite on Earth, and so it was a mathematical certainty that colour television would eventually be a thing of the past once the europium was consumed. But no one now uses europium for the production of red pixels on screens. We use LCD technology. The lesson here should not be lost on anyone. The growth of knowledge is unpredictable, and so we should have a stance of optimism with regards to what people can actually achieve when left to their own creative capacity to learn and discover. My key takeaway from this chapter is that nothing is a resource until the knowledge of why it is has been discovered. It is only knowledge that changes rocks into pure metals or uranium ore into electricity. Chapter 18. The beginning. It is sometimes claimed we are near the end of discovering everything that is to be discovered. That not merely is the human mind finite in scope, but the very laws of physics themselves have almost all been discovered. This was even the prevailing view under Newtonian physics at the end of the 19th century. It was thought Newton was lucky to have uncovered the laws of physics. Einstein and his relativity, and Einstein and his quantum theory, and the quantum theory of lots of other people, showed that impulse wrong. But it's not gone away. John Horgan wrote a book called The End of Science, which captures the mood of many scientists and even physicists. There isn't much more to know on this view. People talk about a final theory of everything, where the four known forces are unified, and then we will have an equation for printing on a t-shirt that will be able to predict everything that happens anywhere forever, in principle. Or, once we have a complete understanding of neuroscience, then we will have a complete understanding of the human mind. Once we have a complete understanding of genetics, then biology will almost be done. But all of this is terribly pessimistic. It says that progress must come to an end in this place or that place, and perhaps altogether. It also says we aren't error-prone. But our fallibility means that we will never have perfect knowledge. Error is simply a part of us and our knowledge, and this is wonderful. It means error correction must go on forever. It means there can be no final theory, and so progress has no wall before it, beyond which no further discovery is possible. We are instead just scratching the surface and always will be. Should we find a way to unify gravity with the three fundamental forces, we can ask, why is G the value it is? Why does it have that strength? Why is that law the one that operates in our universe and not something else? What is the theory that explains the physics we have discovered? We will want to go deeper. Are there actually other universes with other physical laws? In what sense were other laws even possible? If they are possible, where are they? If not possible, why not? Our future understandings of deeper reality are still before us. But we can rule out some bad ideas now. For example, quantum theory is not fully understood, whatever that can mean, fully. There can be no fully. Nevertheless, some people have postulated that because we live in a multiverse, we might be immortal. This is on the theory that should you die in this universe that you occupy, you persist in the others. And the problem with this is, well, we don't understand the place of consciousness in the multiverse exactly for a start. And besides, if you are a person who did not just commit quantum suicide, or just plain old suicide, why should you then suddenly become the person that did? A person that survives quantum suicide presumably does so because they never actually did commit suicide. That person who actually did commit suicide, they're no longer part of this strange thought experiment. We don't know enough. We can also rule out living in a matrix, or Plato's cave, or being deceived by Descartes' demon, or that we are simply dreaming reality into existence. The most recent famous example that's logically equivalent to all of these is, of course, Bostrom's simulation argument, which says that in the future people will build supercomputers on which whole universes or even whole multiverses will be simulated, and those will outnumber the number of base realities. Presumably there's just one of those, so we should presume to be in a simulation. We can become superhuman. We already are compared to the ancients and those people drawing in caves. We can go on extending our lives and extending our reach. My key takeaway for this chapter is a special one. It's simply quoting the last 3 sentences of the book. Quote, "There is only one way of thinking that is capable of making progress or of surviving in the long run. And that is the way of seeking good explanations through creativity and criticism. What lies ahead of us, in any case, is infinity. All we can choose is whether it is an infinity of ignorance or of knowledge, right or wrong, death or life." End quote. Well, there we go. That is my omnibus episode going through all 18 chapters of the beginning of Infinity in 99 minutes. And all because I still continue to regard this book as the most groundbreaking book of the 21st century. I can't claim to have read all the books from the 20th century. I think The Fabric of Reality might be there at the top of that particular century. And we don't know what's coming next either. Maybe David's next book. Throughout my podcast series, I still plan on referring more to the beginning of Infinity. And next episode, we will have the complete interview, episode 100, between myself and David Deutsch. And then episodes 101 and 102, Ask Me Anything episodes as well. So there's a lot to come on the theme of the work of David Deutsch, the beginning of Infinity, and associated ideas. But until next time, bye-bye.